How's it going, everyone? My name is Rory Reyes, and I hope everyone's doing well during finals week. I'm happy to introduce to you my final semester project, which is a two-layer secure password generator. A little background information. So there are several password generators used all over the internet. One of the most common ones is a random password generator. Uh, it takes an input from a random or pseudo-random number generator, which creates the user's new password. However, the con is they're tricky and many programs don't generate random characters in a way that ensures security. Another method is FIPS 181. They're found in many computers that we use today. It's an automated password generator that converts random bits into pronounceable words suitable for a passphrase. However, in 1994, there was an attack where a hacker broke into 1% of accounts based on this algorithm from a research of 1.6 million passwords. The issue is this algorithm utilizes non-uniformity in distribution of passwords generated. A way to fix this is either creating a longer password or modifying the program. The first layer in my security process is Caesar ciphering. It's one of the earliest encoding systems, probably used by Julius Caesar to communicate with his generals. It takes an arbitrary value and uses it as a way to shift from one character through a number of characters based on that shift value. So if my value is 3 and my input is A, it becomes D. The next layer is Advanced Encryption Standard Ciphering, or AES. It's a key encrypted based on 128, 192, or 256 bits for a plain text, which will take a key and go through multiple rounds before producing a final cipher text. So you'll go through shifting, S-box substitutions, and XOR algorithms. The methodology behind my application is the user will input several elements, including an original password. It must be 16 characters long, alphanumeric, and it will go through the first layer of the Caesar cipher method. I chose an arbitrary value of 3, which will shift each character by 3 based on where it's located. However, I came across a problem where the S-box substitutions takes hex values of A through F only. So the way I resolved it is the 6 letters after F, I corresponded them to the original 6. So G becomes A, Z becomes B. If I had a password DEF123, it becomes GHI456. Then replace with ABC456, which will be inputted into the second layer, which is an AES S-box substitution. I hard-coded a 128-bit S-box lookup table, which will substitute every 2 bits of the password that was inputted into this layer, thus creating my new encoded password. I have a demo set up here where I created a JavaScript prototype to run the back end of it, and the password here will be used to create a new encoded password. And as you can see, it went through the shift and the replacement, and here is a new encoded password. Now if I take the same password, I have a web application where a user will create an account. The user will be Sandor Clegane. Email will be sandyclegane@gmail.com. Name him Sandy Clegane. Actually, let's name him Sandy Hound. Password will be the same. Submit that. All right, so all these values are input into a SQL database, and I will retrieve that with this get encoded password query. So if we put in the username, just take out that space, put the F the king password, get the encoded password, and there's the password. Now I have a login page where type in the username, password. If I put in the original password, I have to use encoded version. So if I copy this, put it there, login successful. So in conclusion, we can debate what makes a great password. Is it better to use a high secure password generator on the internet, or is it better for the user to create the password based on its length and different character patterns? Should it be related to the user? Should it be unrelated to the user? Should there be some sort of relation? I believe more layers of security, the stronger. And one of the ways we can update my application is add a random number generator for the Caesar shift. So after every account created, it will be a new shift value, even when a new password is needed. We can implement a full AES Cipher with keys, so it'll go through all the multiple rounds and all the security process involved with that method. Thank you for listening. I hope everyone does well in their finals. Take care.